We'll proceed in parameterization of surface and volume. We'll take few examples. Completely drenched again. It is historic rain and it is raining full night, very, very heavy rain. It is downpouring, that is a better word. So probably it would be pragmatic that I change it. Okay, I believe it is better. So we will see the parameterization and how we will take some example. Parameterization in calculus integration is something that is the future. Future in a sense that it talks about kind of vector also. So vector is crucial in calculus. So the vector is considered as the future in calculus because it has direction and it has magnitude. So it has direction and it has magnitude. Okay, so how much we have covered till now? So how much we have covered till now? So that is the question. So we have covered almost everything in the parameterization. So parameterization is nothing but delegating a work to another coordinate system. So if I have a coordinate system xy, that is Cartesian coordinate system, and my work doesn't happen over there, then I may take help of another coordinate system like polar coordinate system, cylindrical coordinate system, a spherical coordinate system, or anything else. So there are two things that arises in parameterization. The one thing is algebraic parameterization and another is vector parameterization. So algebraic parameterization comes into the picture when we are calculating some area, volume, something like that. Like if I am calculating the volume of a sphere in Cartesian coordinate system, then it is fxy dxy plane, fxy dxy plane, where integration is over a region. If integration is over a region, okay, in xy plane, I have a surface. I have a surface and this is xy plane. This surface maps to some xy coordinate in xy plane. This is called region. Okay, so if I have a surface, okay, so this is, I have a surface. This is hollow cylindrical surface. Now this is xy plane. Now this surface, if I take that, it goes and it maps to a certain region in xy plane, circular region in xy plane. So if I'm trying to calculate the volume of this cylinder, then I can say fxy, that is the equation of the surface of the cylinder, fxy dxy plane, integration over the region that maps on the xy plane, that is a circle. So integration over the circular region on xy plane, fxy dxy. This is for a cylinder. Okay, for a sphere, same thing. So generally we give example of a sphere, then it is a square root of fxy equal to square root of or paraboloid, then I believe it will be x square plus y square. Fxy, that is z, equal to x square plus y square. Alpha x square plus beta y square. Or for cylinder, it is fxy equal to square root of a square, that is the radius of the sphere, x square minus y square. Certainly there would be some equation for the cone, some equation for the cylinder. Okay, so that is the scenario, and then I have to integrate this along the xy plane. If I integrate it along xy plane, it gives me the volume. If I take typically, if I take the example of a sphere, then a square root of a square minus a square root of a square minus x square minus y square. This is the kind of fxy, that is z, dxy plane. It is very difficult to integrate square root of a square minus x square minus y square dx dy. Then we take help of parameterization, where x equal to r cos theta and y equal to r sin theta. This is polar coordinate. And then dx dy, that is dxy plane, I can change into dxy by d theta r into d theta r, where dxy by d theta r is called Jacobian, and d theta g and d theta r is d theta into dr. This Jacobian for the polar coordinate is r d theta dr, and whatever the fxy is now a square root of a square minus r square. The circular region, earlier it was x was minus a to a, y was minus a to a. Now theta is 0 to 2 pi and r is 0 to a. Now it gives me the hemisphere volume. We change. So if I have an independent component x and y, independent component plane xy plane, if I delegate this xy plane to theta r plane, now xy plane itself is dependent upon theta r, and z fxy is dependent upon x and y. Earlier, z was dependent upon x and y. Now x and y is dependent upon another plane, theta r. This is delegation of the work to theta r plane. Okay, there are two things. Once I change it to theta r, do the integration and bring it back into the xy plane again. So the limit would be in x and y only, or change the limit altogether in the theta r plane. Two ways. There is another thing that is in parameterization is parametric vector. Parametric vector comes into the picture mainly when we think about area vector, volume vector. Like if I have a sphere, then if I need an area vector, then any point on the sphere can be denoted as x comma y comma z, xi plus yj plus zk, where z is dependent upon x and y, xi plus yj plus square root of a square minus x square minus y square z. Now, if this is position vector, then area vector I can have dp by dx, dp by dy cross product. This is the area vector. Parametric vector. If this area vector we are calculating, it is again difficult to solve it. Then we go for kind of parametric vector. Now position vector is function over xi plus yj plus zk. Now since x equal to gub, function over ub, function over theta r, y equal to hub, and z equal to fxy. Now this position vector I can transform into parametric vector r u comma v. R, on top of it one arrow mark and braces u comma v. R u comma v equal to gub I vector plus HUV J vector plus FXY F and X is GUV comma HUV double bracket close K. Now, if I differentiate this along U vector, U, and differentiate along V, then whatever we are getting, that is Jacobian dxy by duv, that we have already seen. So, the algebraic parameterization and vector parameterization. So, vector parameterization can also be used for getting volume vector. Area vector we get dp by dx or dr by du, dr by dv cross product. Whereas volume vector, like if I have a surface, a spherical surface xi plus yj plus zk, then it can be demonstrated as a function of volume, that is like a spherical coordinate system r, theta r and phi. So x becomes g theta r phi, and y becomes h theta r phi, and then f is z is anyway function over x and y. In a spherical coordinate system, we have terminology for z also. That is, again I can say, anyway I can say fx comma y, f g comma theta r phi h comma theta r phi and double braces close. This is the vector notation, parametric vector for the Cartesian to a spherical coordinate system. Now, if I want a volume, then dr by d theta, dr by dr radius and dr by d phi. Make cross product, you get the volume vector. We'll talk about it. So everything will talk. Parameterization is something that should be crackable, and it has indefinite, limitless scope, because it would extend in calculus. I mean, it should extend in artificial intelligence, because in artificial intelligence, if I am getting feature are coordinates. So if I have 10 features, it is 10 coordinate, where it should have non-collinear feature. Since they are coordinate, they should not depend upon each other. Changing one feature should not. If I have 10 features, if I tweak one feature, other 9 features should be completely unchanged. If that is not the case, then you have to go for transformation or dimension reductionability, so that you bring to a set of dimension where it should be non-collinear. Then it falls in a typical orthogonal coordinate system, a spherical coordinate system, orthogonal coordinates, where phi, theta and r, all three are perpendicular to each other. Cylindrical coordinate system, where where the theta, r and z, all three are perpendicular to each other. Polar coordinate system, where theta, that is arc, and radius are perpendicular to each other. So if I have a machine learning samples where the kind of features are there, they should be orthogonal, and then it can be brought up into x, y, z, whatever formula. If someone is not able to do calculus over it, then he can go for transformation, parameterization of vector, parameterization in the algebra. If that is the case, then certainly he must use Jacobian, d, x, y, z, whatever plane by d, the new coordinate plane, because he is changing, right, the coordinate. So that is required. We will take one or two example to understand how actually in real life we do the parameterization. When you do the parameterization, how you substitute a independent variable. If I have y that is dependent upon x, then how I can make x dependent upon u? Or if I have z dependent upon x and y, how x and y would be dependent upon u and v? So what is the relationship between z and xy? Anyway, I know the relationship. What is the relationship between x and y and uv plane? So that relationship, what I should take, That is matter of integrand. In calculus integration, I have limit and then integrand and differential dx dy whatever. Looking at the face of integrand and the limit, someone decide for the actual relationship between newly brought coordinate system. If I have xy coordinate system and newly brought coordinate system is uv coordinate system, what is the relationship between them? X equal to g u comma b. What is g? Function what is g? Y equal to h u comma b. What is function h u comma b? If that is the case, then this relationship should be pondered. Someone should ponder about in the looking at the integrand and the limit. If that is the case, we'll take one example. Consider I want to deduce voltage formula for RC circuit. I have a resistor, I have a capacitor that is connected in a series, and again in full series a battery power source battery is connected. So I have a battery, I had a capacitor, somewhere it is kept. Okay, I have a battery source I have. Okay, so I have a real life battery. Okay, this is a battery, 9-volt battery. Now this battery is connected to a resistor. Resistor is connected to a capacitor and capacitor is connected back to the battery. All three are in series. Battery connected to a resistance R, and then it is connected to a capacitor with capacitance C connected back to the battery. This is typically called RC circuit. Now the voltage across this battery is Vs, V, and at the bottom S, Vs, voltage source, and any moment voltage across capacitor is V, because voltage across capacitor will be zero at the beginning. So when someone switch on the circuit, immediately, if this is only R circuit, not RC circuit, then voltage across resistor would build up immediately. If someone switch on this battery and it connected to a resistor voltage would switch on immediately. But if it is RC circuit, then capacitor tends to oppose any change. It's a lazy guy. So capacitor, the voltage across the capacitor would not build up. It will be zero only. And slowly voltage across the capacitor would build up. The power, it will start absorbing from the battery and voltage will build up. Voltage will come to a stage that it will not build up more than that and it will stop the current flow. That is called capacitor is fully charged. Once capacitor is fully charged, then current flow would not happen. So at the beginning, there will be sharp current flow and capacitor voltage would start building like exponential. Okay, and exponential, it will go up quickly and slowly it will become stagnant and very slowly at the end, it will become a peak voltage. Now, what is the equation of voltage against time across the capacitor? That is the question mark. What is the voltage across the capacitor equation against time voltage build up? That is the question. Now, voltage across capacitor is charged by capacitance. This is what I believe so. Means voltage across a capacitor is equal to how much charge it has stored divided by capacitance. I mean dv by dt equal to dq by dt into 1 by c. dq by dt, the charge per second is the current. So dv by dt equal to current into 1 by c. Means if capacitance of this capacitor is high means dv by dt will be low. The change in voltage across the capacitor will be low. If it is capacitor is of low capacitance, then change will be high. Means quickly it will charge, quickly it will discharge, quickly it will charge, quickly it will discharge. But if capacitor, like gravity people, means you have high gravity. So if capacitance is high, if you apply voltage, then it will slowly it will charge. dy by dt will be slow. So dy by dt equal to 1 by c into dq by dt, that is current. Now if I take this RC circuit, then voltage source equal to voltage across the capacitor and voltage across the resistor and voltage across the capacitor. Voltage across the resistor is R into I, where I is differential. I initially it will be very high because the capacitor is behaving like a short circuit, and as capacitor is charging, or I would say capacitor can be, like I say, electronics is nothing but game of resistance. That's it. So capacitor resistance is variable. At the beginning, it offers zero resistance, and slowly resistance start growing, and at the end, resistance become infinite and current cannot flow. So in that way, the voltage across the resistor is R into I, where I is variable, and voltage across capacitor is Q by C. So voltage across capacitor at any moment it is V. This is what we are trying to find. And voltage across resistor is any time in R into I, where I is same across capacitor and resistor as per the series. So I dV by dt equal to I by C. So I equal to C into dV by dt. So voltage across resistor is R into C into dV by dt. RC dV by dt. Now, this is the voltage across the capacitor, where dV by dt, V is voltage across the capacitor, and RC dV by dt is voltage across the resistor. So, RC dV by dt plus V, voltage across capacitor, equal to voltage source. Now, it came to calculus. RC dV by dt plus V equal to Vs, voltage source. RC dV by dt equal to Vs minus V, or dt if I take right hand side, and so it becomes and RC also on right hand side, it becomes dV by Vs minus V equal to dt by RC. Okay. Now I have to find formula of V, voltage across capacitor, as per the time. This is the solution. dV by Vs minus V equal to dt by RC. Okay. Now I have to integrate both sides to get V as per the t. But dV by V I can calculate, it is log, natural log of V, dV by V. What about dV by Vs minus V? Now here we need parameterization. Parameterization. Now integration is from 0 to V, dV, change in voltage. So I want to calculate the any time voltage, then I need to do integration. 0 voltage, it started with 0 voltage till V, any time, any point V, whereas dt is 0 to any time t. So dV by Vs minus V, integration 0 to V, equal to dt by RC, integration 0 to t. This is what I want, where V is voltage at any time t. Both are variable. Now what is integration of dV by Vs minus V? Integration from 0 to V, that is dV. Now looking at the integrand is 1 by Vs minus V, differential is dV, limit is 0 to V. So Vs minus V I can parameterize as x. I can parameterize, or u, dVs minus V equal to u. dVs minus V equal to u. If that is the case, what about the limit? What about the differential? What about Jacobian? So if I say integration 1 by Vs minus V dV, and dV I want to change into u, as per our principle, dV is nothing but dV by du into du. So du is changed to du. Now dV by du I have to find. Okay, now Vs minus V equal to u, minus dV equal to Vs is constant, minus dV equal to du. So silently I can replace dV by du to minus minus. That's it. Minus dV equal to du, dV by du equal to minus 1. So now it turned into 1 by u minus du. Integration, minus I can keep outside, or minus I can shift that side, and we have now integration du by u equal to integration 0 to t 1 by rc I can keep outside dt. dt integration becomes t, minus I had shifted minus t by rc, minus t by rc, and integration of du by u is ln u. Now I have logarithmic of u. Okay. Now can I silently switch u to vs v? Now I have two coordinate. One is v coordinate, function over v, and I have u coordinate, two coordinate. Now I got the integration, right? ln u. ln u I can silently bring it back to vs minus v. This is one solution. So ln vs minus v. Okay, this is where v is 0, integration is 0 to v. If I put 0, if ln vs minus v, so if v is 0, then it becomes ln vs minus, then v ln vs minus v. So ln vs minus ln vs minus v. Minus minus ln, it will come as division. ln vs by vs minus v. ln, I can switch that side, it becomes exponential. So vs by vs minus v equal to exponential of minus t by rc. Okay, so vs, so vs equal to vs by v minus v would go that side. Okay, someone had to settle it down. This would be the formula of the v. I believe it will come v equal to vs in braces 1 minus e to the power t by rc. This is what it will come. Okay, now I can try other way. Now I had got ln u as the net integration. Let's do everything in u only. Limit is 0 to v. Now vs minus v equal to u. When v equal to 0, u is vs. Lower limit is vs now. Upper limit is vs minus, upper limit is v. V means u equal to v, vs minus v. So vs to vs minus v. vs to vs minus v. I believe it came other way. Okay, so someone has to take care. So it is ln vs minus vy vs. That is better. That is the actual one. ln vs minus vy vs. ln would go that side, and it is vs minus v divided by vs equal to exponential to the power minus t r by c. Okay, now vs I can take that side, and this vs that side, and here and there it will become v equal to vs braces 1 minus e to the power minus t r by rc. I think this way we can get. That way someone can refine it. So this is the integration for with the parameterization. If someone is using parameterization, be careful when you make the relationship with the new independent coordinate system from v to u. Calculate the Jacobian correctly, or bring, and then after doing the integration, bring back to the previous coordinate system or change the limit. Okay, and you get the answer. What is the next thing example we can take? A very prominent example that we are taking. Now consider that I want to calculate area of a circle. Area of a circle I want to calculate. Then area of a circle, then I can take a circular region in xy plane, and fxy I can take 1. So I can calculate volume. So fxy dxy plane and integration over the region, circular region. I'm trying to calculate the volume, but since height is one constant, I land up in calculating the area of the circle only. So it is integration now, integration 0, the x is minus a to a, x is minus a to a circle, y is I can say 0 to a square root of a square minus x square. We are calculating semicircle now. And then dx dy, dx dy. So dy integration will be y, and if I substitute, it becomes square root of a square minus x square. You would say it is like fx dx. So we are in a way to calculate volume, and we came to simple fx dx. Now a is minus a to a, and dy came to y, and 0 to square root of a square minus x square. So it is integration of square root of a square minus x square dx and minus a to a. Semicircle area we get. I have a typical example. It may not be kind of a semicircular region or whatever. The example is there is a dual integration. One integration is 0 to 2. X is 0 to 2. Y is 0 to a square root of 2x minus x square. And then square root of x square plus y square dx dy. Okay, I believe the question is straightforward. There is a integration, double integration. X is 0 to 2, y is 0 to a square root of 2x minus x square, and then integrand is a square root of x square plus y square dx dy. Someone has to calculate. Now, if we see it closely, now question arises, what should I do? Which I know that here looks like it is x and y, but x and y, this is a volume calculation. fxy is a square root of x square plus y square. Don't jump into integration quickly. The best way to do integration is to understand the graph, what it is doing. If there is a double integration, one is 0 to 2, that is x, and y is 0 to a square root of 2x minus x square, and then integrand is square root of x square plus y square, and differential is dx dy, means xy plane. I am trying to integrate a formula that is square root of x square plus y square. This is formula of a sphere, formula of a surface, fxy dx dy, where the integration is a region on xy plane. What is the region? 0 to 2, that is x. Y is square root of 2x minus x square. 2x minus x square is nothing but 1 minus x minus 1 whole square. Same thing. 2x minus x square is 1 minus in braces x minus 1 whole square. It will be same. 1 and then minus x square plus 1 minus 2x. If you settle it down, 1 gone, and it is 2x minus x square. What is 1 minus in braces x minus 1 whole square? This is the equation of a circle. Y equal to square root of 1 square minus x minus 1 whole square. This is equation of a circle centered at 1 comma 0. If it is 1 minus x square, quickly someone will say this is a circle. Y equal to 1 minus x square root means x square plus y square equal to 1. This is a circle centered at the origin with circle radius 1. Y equal to square root of 1 minus x minus 1 whole square is nothing but x minus 1 whole square plus y square equal to 1. Again, circle of radius 1, but centered at 1 comma 0, x minus 1 centered at 1 comma 0. This proves that if this is x-axis, okay, if this is x-axis, then circle is like this. If this is x-axis and this is y-axis, circle is like this. Circle is like this. Circle is not centered at the origin. Circle is here. and centered at 1 comma 0 with radius 1. So right side is 2 comma 0, left side is origin, up is 1 comma 1 and down is 1 comma minus 1. This is the circle. Someone has to find 0 to 2x, y is 0 to square root of 2x minus x square, and then a square root of x square plus y square dx dy. Probably someone can try. This is typical calculating the volume of something that is square root of x square plus y square. So this is xy plane and there is a surface, a square root of x square plus y square. I am trying to calculate the volume of the surface under which the xy plane region is a circle that is centered at 1 comma 0. This example is famous, but solution is not famous. At least I could not understand the solution at all. So before doing the parameterization, first understand what is the question. Draw it, and then you'd go for parameterization. Again, draw it in parametric way. Then think about the limit and think about whatever it is. Now, for the parameterization of a circle, the best way for the parameterization of a circle is polar coordinate system. So, x equal to r cos theta and y equal to r sin theta. You say r is, I know 1. No, you cannot take 1. R you cannot take 1 because you have to calculate for a region. You are not calculating a circumference of the circle. Then you can take R constant as 1. Region, where region is full area on the region. So x equal to r cos theta and y equal to r sin theta. So here x is, here it is not centered at the origin. So x minus 1 equal to r cos theta. If it is x minus 1 equal to r cos theta, then y cannot be r sin theta. Then y will be 1 plus x minus 1 equal to r cos theta. Y equal to square root of, y equal to square root of 2x minus x square. Okay, or square root of 1 minus x minus 1 whole square. Then 1 minus r square, y equal to 1 minus r square cos theta. Y equal to square root of 1 minus r square cos square theta. Whatever it is. No need to get frightened. So anyway, now integrand is the square root of x square plus y square. Y square equal to, anyway, y square equal to square root of x 2x minus x square. So y square will be 2x minus x square. X square gone. It is a square root of 2x. So integration is a square root of 2x dx dy and integration over the circular region. That's it. So circular region 0 to 2 and 0 to square root of 2x minus x square. So upper semicircle is the circular region, not the full circle. Okay. Now the theta will be 0 to pi, not 2 pi, and r will be 0 to 1. That is the radius. So 0 to 1 and 0 to pi. And here square root of 2x dx dy. So dx dy, what is, now if I convert into theta or plane, okay, now x equal to dx dy. Now x minus 1 equal to r cos theta, and then y equal to, if x minus 1 equal to r cos theta, then y will be 1 minus whatever it is. Okay, 1 minus r square cos square theta square root, whatever it is. Now someone has to calculate the Jacobian and then square root of 2x. Square root of 2x is nothing but 2 plus 1 plus 2 into 1 plus cos theta. 2 I can keep outside. Square root of 2 into square root of 1 plus r cos theta. I believe so. So square root of 1 plus r cos theta. Jacobian dr d theta, where limit is semicircle, so 0 to pi and 0 to 1. Okay, calculate this as take this as an assignment and calculate the integration. So this is how someone has to proceed in parameterization. Someone can try simpler example also, like y is 0 to a square root of 1 minus x square. X is 0 to 1 and y is 0 to a square root of 1 minus x square. Instead of square root of x square plus y square, it is x square plus y square dx dy. This example also, we will talk about the solution of this example. I believe maximum thing is done. So someone can try it out.